Welcome class, everybody. We're going to start off with a few review questions. So if you want to head to the board and try this example, certainly welcome to do that, but I do want everybody to try this, whether you're at the board or at your seat. So take a look at this, and let's pause the video for a few minutes and let everybody give this one a try. And when you're ready, just push play, and we'll see what the solution looks like. All right. To find the slope and the y-intercept of a line, we want to be in slope-intercept form. And slope-intercept form means that the equation we're working with, the linear equation we're working with, has to be solved for y. So in order to solve for y, what I need to do here first is I need to get the 3x term over to the right. I need to get it away from the y term. So I'm going to subtract 3x from both sides. This, when I subtract, is going to give me negative 5y equals 10 minus 3x. Keep in mind the 10 minus 3x are unlike terms, and so they cannot be combined. So I have to just write it like that. A final step to get the y by itself would be to get rid of that negative 5. In order to do that, I need to divide every single term on both sides by negative 5. So when I divide both sides by negative 5, I end up with the y by itself, and y is equal to negative 2, because a positive divided by a negative is a negative, and plus 3/5 x. The reason why it's plus is because a negative divided by a negative is a positive. Now from here, I can now compare this with what I know slope-intercept form to be. Slope-intercept form is y equals mx plus b. And of course, what we have right here is written in a slightly different form. This is actually written in y equals b plus mx. It's still slope-intercept form. We can pick out the slope and the intercept from this. So what I want to recognize here is that my b is negative 2, and of course the b is the y-intercept. So I would say that the y-intercept is, sometimes we'll say negative 2, but it would probably be better written as 0, comma, negative 2. And then the slope is the coefficient on the x. So in this case, that would be the 3/5. We can see that 3/5 goes with the m, and so we would say that our slope is 3/5. All right, so I hope that worked out well for you. We're going to go ahead and do a new, different warm-up example next. So for our next warm-up question, we want to try this one here. I want you guys to try to write the slope-intercept form of the line that has a slope of negative 3/5 and a y-intercept of 0, comma 7. So again, please pause the video and let's give everybody a chance. Love to have as many of you at the board as we can. If you happen to be at your seat, I want you guys to try this at your seat as well. So go ahead and pause the video and try this one. All right, in order to get this one done right, here's what we need to do. First of all, we need to recognize what slope-intercept form is. Slope-intercept form is y equals mx plus b. And we want to remember what the m and the b stand for. Of course, the m stands for slope, and the b stands for the y-intercept. So all we need to do here really is to plug in the numbers in the appropriate places. So I know that my slope is m, and I'm told up here that my slope is 3/5. So I'm going to put that 3/5 in place of the m. So I'd get y equals negative 3/5 x. And then, of course, the y-intercept is the b. And I know my y-intercept is 0, comma 7. So I'm going to put the y-coordinate in there because that's the y-intercept. So in place of b, I'm going to put plus 7. And that is the slope-intercept form of our line. Hope that went well for you. We'll do a couple more warm-up examples. All right, so for this one, if you're at your seat, you're going to want to perhaps use some graph paper. If you're at the board, obviously we don't have that. Just do your best with this. I've got to get this grid here on my screen to use. The instructions say use slope-intercept form to graph 2y minus 3x equals negative 8. Go ahead and pause the video, give this one a try, and check out the solution when you're done. All right, in order to use slope-intercept form, we need to be in slope-intercept form. And right now, the line as it's currently written is not in slope-intercept form. So I need to do that. And to accomplish that, I need to get the y by itself. To get the y by itself, the first thing I need to do is to add 3x to both sides. So when I add 3x to both sides, I'm going to get 2y equals, I'll write it like this, 3x minus 8. You could write it as negative 8 plus 3x. It'd be the same thing, but I'm going to write it like this. Finally, I need to get the y by itself, and so I need to divide by 2 on both sides in order to accomplish that. So it gives me y equals 3/2 x minus 4. Now from this, what I want to do is I want to identify the slope and the y-intercept. So I'm going to just write slope-intercept form down here. Y equals mx plus b. Now from that, I should be able to identify what the slope is and what the y-intercept is. So what I'm looking at here is that I can see that 3/2 is in the place of the m, and I know that m is my slope, so I'm going to write slope is equal to 3/2. And I can see that the negative 4 is in place of the b, so I'm going to write that my y-intercept is negative 4. So when we graph these, what we'll do is plot the y-intercept first. The y-intercept is at negative 4, so I'm going to plot that out here. I think that's right about there. And then from there, I'm going to count off my slope. And if you remember, we want to try to use what I call a slope triangle to count this off. So I'm going to do this in yellow. My slope is 3/2. Let's remember that slope is rise over run, so I could write that down here if I want. That means that from my y-intercept, I'm going to rise 3, and I'm going to run 2. So that means I'm going to go up 3 and right 2, and that'll give me another point that is on the line. And I could do that maybe one more time if I want. So from that point, I'm going to go up 3, right 2, and that would give me a third point. And at this point, I would try to connect the points with as straight of a line as I can. And that's not always easy. I'll do my best, something like that. And this line should have arrows on the end of it, like so. And that would be the graph of that particular line. Let's remember, for a quiz or a testing purpose, you do want to have the little points marked clearly like I have with those dots, and then you also want to have your little slope triangles, at least one of them, drawn out there, just signifying that you know how to count off your slope. Again, I hope that went well for you, and I think we will do one more warm-up before we get started with today's lesson. All right, so let's read the question together here. Again, please be trying these at the board. If you're at your seat, you need to be working on these at your seat. It says, are the following lines parallel, perpendicular, or neither? Then I'm giving you line A and line B. You can see we've got a couple of different equations here, and we want to decide, again, the question is parallel, perpendicular, or neither. So again, pause the video, give this one a shot, and then watch the solution. All right, in order to judge whether two lines are parallel, perpendicular, or neither, we need to be looking carefully at the slopes. And so I can see here the line A is already in slope-intercept form. Y equals mx plus b. And so from this, I should be able to pick out the slope pretty easily. I can see that the slope is the number that is attached to the x, or the coefficient on the x. And so for line A, I have a slope of negative 5/3. Now, I don't immediately know the slope of line B because it's not in slope-intercept form, but I can get it there pretty quickly and make a judgment on that. So in order to get to slope-intercept form, I'm going to need to subtract 5x from both sides. So that'll give me 3y is equal to 21 minus 5x. And then finally, I need to divide both sides by 3. And in doing so, I get y equals 7 minus 5/3 x. And so the idea here is that I should be able to pick out the slope from this slope-intercept form. And as I do that, I look right here. And sure enough, look at that slope. That slope is negative 5/3. So as I compare the slope of line A with the slope of line B, I, of course, can see the pattern that the slopes are the same. They're equal to each other. And the principle, of course, is that if the slopes are the same, or if the slopes are equal, then we would say that the lines are parallel. So I hope that worked out for you with this final warm-up question. We're going to go ahead and move into our notes. So if you will, go ahead and get out your notes packet. And we're going to work on section 3.6 today in our class. All right, so in section 3.5, we looked at a slope of linear, or a form of linear equations called slope-intercept form. And in section 3.6 today, we're going to be looking at a different form that is very useful as well. This is called point slope form. And so I want to highlight that here for you. This is point slope form right here. So point slope form is y minus a y coordinate equals m times x minus an x coordinate. And let's make sure we remember what these different pieces might mean. M, of course, still stands for slope. And x1 comma y1, this stands for a point that is on the line. A point that is on the line. So this is going to be just an x comma y coordinate set. And let's talk about where this comes from. If we remember back to the slope formula, maybe you remember m is equal to y2 minus y1 over x2 minus x1. If I were to multiply both sides by the denominator on the right, so if I were to multiply by x2 minus x1, and multiply the left side by the same thing, let's think about what would happen. Wouldn't this cancel over here? And I would just end up with x2 minus x1 times m is equal to y2 minus y1. And then we take this and adapt it to being a linear equation form, and we're going to say, well, we want our x2 and our y2 to simply just be the y and the x variable. So I would say then x minus x1 times m is equal to y minus y1, and we have this new linear equation form called point slope form. We're going to find this to be extremely useful, and we can actually adapt this as well to eventually end up at our old form, slope intercept form, but I hope that you'll find this to be pretty straightforward. So let's go ahead and take a look at our first example. All right, for our first example, example number 1, I want to work this one with you. So if in your notes packet, if you could please work on this together with me, I'm going to go ahead and work through this slowly. And of course, if at any point you'd like to pause the video, rewind it or something, you certainly can. So the question says, find the point slope equation of a line that has the slope of -5 and passes through the point 1, -7. And after we've done that, we're going to transform this over to be into slope-intercept form. But we're going to start off by putting it into point-slope form. So I'm going to go ahead and write that down to remind us of what that is. Point-slope form is y minus y1 equals m times x minus x1. Let's remind ourselves that m is the slope still, and x1 comma y1 is just a point that is on the line. So if we can figure out which piece goes where, getting point slope form really is just a matter of plugging things in where they go. So I want to try to point that out to you. First of all, we see that the line we're dealing with has a slope of -5, so I'm going to go ahead and drop that in right there in place of the m. So it's going to be equals -5. And then I need to fill in for the x1 and the y1. So x1 comma y1 is simply a point that is on the line, and that, of course, would be this 1, -7. So, of course, the 1 is an x-coordinate, so I would then plug that in for x1. I would get x minus 1. Again, all I'm doing is I'm taking this 1 and I am dropping it in right there for the x-coordinate of the point on my line. And then, of course, the -7 is a y-coordinate, and that is going to be going in for y1. So it's going to be y minus -7. And to finish this off, maybe we could write y plus 7 is equal to -5 times x minus 1. And that right there is point slope form. So all I did is I plugged the slope in where it goes, I plugged the x-coordinate and the y-coordinate into those two appropriate spots, and I've got point slope form. So at this point, we have accomplished that first task of getting to point slope form, and we're done with that. Okay, so it also does ask us to take this to slope-intercept form, and to do this, we just need to remember that slope-intercept form is going to have to be solved for y. We're going to have to do a little bit of simplifying on the way, but I'm going to go ahead and come down here to get to slope-intercept form. So I'm going to start off with y plus 7 equals, and what I would want you to notice first, of course, on the right-hand side, I hope that you see that distributive property, that -5 could be distributed here and here. that would give me y plus 7 equals negative 5x plus 5. Still don't have the y by itself, but I can do that pretty easily by subtracting 7 from both sides. When I do that, I'm going to get y is equal to negative 5x minus 2. At this point, I'm in slope-intercept form, and so I have accomplished the second task that I was asked to do. So these two forms are the exact same line. They're just different forms for that exact same line. If you were to graph either one of them, you would end up with the exact same line. They just are in a different form at this point. Both useful for sure. I hope that you'll find this process that we went through at the end, going from here to here. I think you're going to find that to be of particularly important use moving forward. Okay, so we're going to move on to example number 2. But of course, if you have questions, feel free to go back and rewind the video, ask each other questions, and make sure that everybody's doing pretty well before we move on to example number 2. Okay, so for example number 2, I do want you to try this with your table partner. It says find the point slope equation of the line that passes through 3, 3 and negative 5, 2. And then, like before, we're going to try to write that equation into slope-intercept form in the end. But the first task is to write point-slope form for this equation of the line. So go ahead and pause the video, try this with your table partners, and we'll check the answer in just a moment. All right, I hope this one went well for you. Let's check it out. Before we do anything, really, we need to figure out what the slope of this line is. We were not given that, and so we're going to need to figure that out first. So I'm going to do that off to the side here. We've done this quite a few times. Let's remember that slope is equal to y2 minus y1 over x2 minus x1. It's the change in the y's over the change in the x's. So I'm going to call this point number 2. I'm going to call this point number 1. So to find slope, I'm just going to plug the appropriate coordinates in where they go. So it's going to be 2 minus 3 over negative 5 minus 3. That is going to give me negative 1 over negative 8, which gives me positive 1/8. So that's my slope. So whether I'm in slope-intercept form or point-slope form, it really doesn't matter. The slope is going to be 1/8. So my first task then is to write the point-slope form of this line. And so all I need to have the point-slope form is I need to have the slope, which I have, and I need to have a point that's on the line. It just so happens that I have 2 points, and so that I actually could use either one of these points in my point-slope form. So here would be one way of looking at this. I could say, again, let's remember point-slope form is this. It is y minus a y coordinate equals m times x minus an x coordinate. And so I could use that first point. I could use 3, 3 to help me with this. And if I did, I would write y minus 3 is equal to 1/8 times x minus 3. And that would be point-slope form. That would be one way I could do it. The other way, this would be an alternative answer. This one right here being fully correct, 100%. I could also write, I could use the other point, the negative 5, 2. So with that, I would write y minus 2 equals 1/8 times x minus negative 5. And of course, minus a negative is really plus a positive. So it doesn't matter which point you use. Either one of these is going to work out fine. I know they look a little bit different here, but I think that regardless of which one you use, we're going to see that in the end, slope-intercept form is going to be the same regardless. So that is going to be my next task. Again, just encourage you to rewind and rewatch if needed, if there are any questions about how we got what we got. But really, point slope is simply plugging the slope in where it goes and then plugging the point in where it goes. Just so happened we had 2 points to choose from on this one. So that's why there's 2 possible answers. On a quiz or a test, I'd give you full credit for either one of those because they're both right. All right, so to go to slope-intercept form now, I just need to take one of these and solve it for y and get everything all simplified into y equals mx plus b format. So I'll just take the top one. Either one will work. First thing I'm going to do is I'm going to distribute that 1/8. So I'm going to get, if I do distribute it, I'm going to get y minus 3 equals 1/8 x minus 3/8. Just distributed that 1/8 across. And then finally, I need to add 3 to both sides. When I do that, I'm going to get y equals 1/8 x. And I need to get a common denominator and add, so it's going to be negative 3/8. And then the 3 converted over to eighths would be plus 24/8. So my final slope-intercept version of this would be y equals 1/8 x plus 21/8. All right, so whether you worked with the first or second point slope form, when you go to slope-intercept form, you should end up with that right there. Okay, we have one last example to try, and let's go ahead and try this one with your table partner as well. It's example number 3. All right, so here is the solution to example number 3. Hopefully you've tried this with your table partner already. Things have gone well. This one says, write the point slope equation of the line with slope 4/7 that passes through the point -4, -3, then graph the line. All right, so that's exactly what we're going to try to do here. Let's remind ourselves that point slope form is y minus a y coordinate equals m times x minus an x coordinate. So it really comes down to me plugging things in where they're supposed to go. I can see my slope is 4/7. So I'm going to drop that in there right in place of m. So that's going to be this right here. And I can see that my x coordinate is -4. So I'm going to drop that in right there in place of my x coordinate. So it's going to be x minus -4. It's going to end up being plus a positive, of course. And then finally, my y coordinate of the point that's on the line is going to be -3. I'm going to be dropping that in right there. So it's going to be y minus -3, which will, of course, end up being y plus +3. So if we clean that up a little bit, y plus 3 equals 4/7 times x plus 4. So we have not yet graphed out of point slope form. So I'm going to do that now. I'm going to get rid of some of these arrows and such. And I'm just going to use the information here to help me get things figured out as far as how this would graph. So I can see right here for sure that the line passes through the point -4, -3. So I'm going to plot that right about there. It's the point -4, -3, yeah. And then we have a slope of 4/7. And so I know that -4, -3 is actually on my line. And so I'm going to count my slope off from there. My slope is 4/7. So that would be up 4 and then right 7, which I think would take us to be right about there. And at the end of that little slope triangle, I'm going to put my second point. And it looks like I might be able to fit one more on here. Let me try it. So to count off another slope, I'd go up 4 and then right 7. So let's see here, 2, 4, 6. Yeah, it'll put me right on the edge of the graph there. That would be where my third point is. Remember, you only really need 2 points. I'm just doing a little extra to help you see it. Okay, so then all I need to do to finish this one off is to connect my points, hopefully with a nice straight line that makes sense. Looks all right. And we always want to put little arrows on the end of our line indicating that it goes on forever, that it's infinitely long, but that would be a good graph of that line. So I don't know if this is any more or less difficult than slope-intercept form. You're just getting a different point to use here, but it does graph similarly in regard to the slope. All right, so that's it. Hope that worked out well for you. When I see you again on Wednesday, we'll be going over your quizzes that you took last time and perhaps review this a little bit as well. Hope you have a great day. I'll see you soon.